again, good morning everybody. I hope by now your morning coffee or whatever routine that you have in the morning to get awake, to get your brain working, is working, because we're going to go quite low into the Flowable engine. We're going to look at running Flowable on Mongodb. We're going to look at the code that actually needed to make this happen, and at the end we're going to top it up with some machine learning, and all of that within 45 minutes. Possible. But before we do that, we have to look at a few fundamental things. So I think we kind of hinted on it already multiple times, is that Flowable relies heavily on database transactions, on the transactional semantics of a relational database. And we use it for multiple things, conflict resolution, optimistic locking. The main use case is to guarantee that when you have one step and you have another step and there's any number of steps in between, that the engine moves you atomically, between quotes, atomically from these steps. Now I'm putting between quotes because, of course, if you're a technical guy or a developer, or you just know how these things work, atomically is really hard, if not impossible, when you're working with real systems. So atomically, in this sense, really means business atomic. You guarantee from the engine's guarantee from a business point of view that you move atomically from one step to the other, being it process, being it the case. That's what the engines give you. Now, that doesn't mean, of course, that you have to stop being a good developer, because you still have to think about service failures, you have to think about exception use cases, what if something goes wrong. But at least with this mental model and knowing that the engine guarantees you this, it becomes much easier. Now, we've been following MongoDB for quite a while, but our interest was really triggered, I think back in January, February, when they announced that they would do transactional support, full transactional support, ACID transactions on MongoDB. And lo and behold, at the end of June, they actually released 4.0, which contains support for ACID transactions. So we started writing what we're now presenting, and yeah, you'll see the results of that. Now, for the people that don't know MongoDB, it's basically a NoSQL JSON document. So that means that you put JSON in, you get JSON out, you query by JSON, everything JSON. Right? That is what MongoDB is. It started in 2007 as a small component of their platform as a service that they had back in the day. It turned out that this thing was the most important thing, or the people loved this part the most, and as history has it, that became the MongoDB, the company as we know it now today. In the early days, and especially in the technical circles, it didn't have a good kind of reputation. It was known as the devil database. You put stuff in, it would be gone, data got corrupted, which is not great if you're doing a database project. But they got their act together, and they actually, if you look at them now, the actual official adjustment reports, for example, that go analyze these things, they're actually doing a fine job, and they actually fixed all of that stuff. One of the things which is important to this story is the acquiring of the WireTiger engine at the end of 2014. It is this WireTiger engine that enables these transactional semantics. And if you're interested in those kind of low-level things, there is a really, I don't know if you can read it, but if you share the slides, you can have a look at it. There's a really interesting series of videos on YouTube that they put up, really openly discussing how they did that, how they took this WireTiger engine, how they added transactional semantics. It's really, really, really geeky, really low level, but yeah, I love it. All the code that I'm going to show you today, you can have a look at it on the GitHub link that's right up there. And we're going to jump into the code. I can slide one slide or two slides. But just for that everybody's on the same page. What happens if you do a service call? If you, for example, you start a case or you start a process. You do runtime service, start process instance. What happens is that service call, we're wrapping that logic in something we call a command. That command passes a stack of interceptors. For example, if you're using Spring, it's going to start a transaction and more of that stuff. Once you pass those interceptors, there's the operations. This is really the heart of the engine. There's a set of operations that drive processes forward, and there's like a little run loop that continuously is going to take work from an agenda and is going to execute these operations based on data. Because you need, of course, your current structure, your current tasks, your current variables, and this is fetched through what we call entity managers. And these entity managers are kind of high level. They kind of are knowing more than just the raw data stuff. The raw data stuff is actually, this is really important for this presentation, that's what we call data managers. So think of this as the correct kind of layer. This is the create, read, update, delete stuff that's really there. So when it comes to MongoDB implementation of running Flowable on MongoDB, it's really about replacing this lowest layer, as I will show you in the code. And it turned out that when we started building this, that the MongoDB transactional model, or the idea, actually matches what we had quite nicely. So the way they do it is that they of course have a driver that's been out there for years, so they couldn't just make everything transactional. So they had to add something in a backwards compatible way that's extra on top of what's already there. So what they have is that when you start doing something, you can ask for a client session. This client session, you have to keep it with you, and all the subsequent operations that you execute, you gotta hook that into that same client session. At the end, you say, I'm done, and that's your transaction, right? So that's kind of how they do it. And I'll show you later on, well, I'll show you now how that looks like. Switching takes a bit, all right. So let me first start from the top, and here we go. So, if you want to use a Flowable engine that is backed by MongoDB, that's pretty much how you would expect it. You create a new process engine configuration, you set a connection URL which now points to MongoDB instead of JDBC, and a few settings that we have all the time. So literally that's all you need to do, and you get a process engine out of this, and from that process engine you can actually just do whatever you want. So this, for example, this process service, it gets in the process engine, and what it does is just get the runtime service. Now this happens to run against MongoDB, but this could as well have been against a relational database, right? So that's what the MongoDB integration kind of does. So before we go into the implementation, let me first show you how the relational counterpart looks like. So for example, I'm just going to take, here we go, I'm going to make this a bit smaller. Is this readable at the end? Yep. For example, a very simple example. So remember, we're going through this whole stack, right, from the service to the lowest level. And this is actually, we're now at the MyBath. MyBath is the framework we use for the JDBC kind of work. If you're now at this lowest level, and for example, the one I've taken now is that give me the tasks for a given process instance. Right? Quite simple, just because it makes things easy to explain. What we do is we get a DB SQL session, and I'll show you in a second what that is, and we do give me that thing, which has this name. So if I look for that thing, you can see that this is your plain old SQL in MyBath XML. Pretty much what it does, as you would expect, select something from this table where this column is this value. Quite simple, right? And this DB SQL session, that's really the heart of everything every data manager passes here. So when you start that service call, remember here in this slide that I had, when you start a service call here, one of the interceptors is actually going to create a DB SQL session at that point. So it's going to create this session that only lives during one service call. It doesn't live longer. There's no caching going on whatsoever for the subsequent call, but during one call, this session. It's important to remember because the MongoDB implementation will follow that exact same pattern. So if you have a look at the DB SQL session, what it does, I mean, there's a lot of details here, but in the end, what it does, it keeps stuff for that particular, as the name implies, for that particular session, that particular API call. For example, in the insert, we're flushing the inserts at the end of the transaction. This is the low-level kind of MyBath layer on top of JDBC. And what we're doing is we're mapping, so we're keeping a list of entities. And if we go up here, it should be here. Yep. So we're keeping, it's a map. We're keeping a map of inserted stuff, deleted stuff, and updated. But Des was explaining that we try to optimize these things heavily. So if we see that there is something that updates a certain entity, but that entity gets deleted, then we might decide to delete it anyway because the update is lost anyway. So we keep that session during that API call here, and in the end, the DB SQL session will be responsible for the state, if you can call it like that, during an API call. So now that we know that, let me just show you one more thing. If we take a more advanced example, for example, the one that everybody probably has used is you want to select tasks by query. Well, again, you're going to have to dive into the task XML, and this is a lot of XML here. Don't get scared. But basically, what we're doing here, and I'm just showing you this because I'm going to show you later on the MongoDB stuff and then compare it. Basically, what you're doing is a long kind of comparison of, or the query wants to have something with priority that's equal to whatever, then you do this, then you do this, right? And so you're building up this query. So now that we get that in mind, let's have a look at how it looks like on the MongoDB side. Now, maybe to prove that I wasn't lying, there we go. So the only thing that actually is really different from a MongoDB process engine configuration compared to regular one is that this has a whole list of custom data managers. And that's it. So we only replace, in that slide again, we only replace this lowest layer, the interfaces here, replace that with the MongoDB implementation. So, if you now have a look at this, the same class, but now on the MongoDB side, so this is now called MongoDB Task Manager, not my Batis one. And the one that we had a look at was the process instance, right? There you go. It's quite similar. It's actually, yeah, almost looks the same. The only difference, don't have a look at my failing tests, that's new features coming up. So basically what we're doing here, instead of having this, it's my Batis XML or whatever you have, right? We're now using JSON there, because MongoDB is a JSON database and everything's JSON, so we also use JSON to query. So what we're doing here is we're actually saying, give me a list of tasks and give me all the ones where the process instance ID field property of the JSON is equal to this one. And then you pass it into a MongoDB session. Again, it matches very nicely what we had, right? So if you have a look at the MongoDB session, you'll see it's actually quite close to the one that we had. Sorry, MongoDB session, here we go. The one that we had on the relational data side. Again, there is a list of inserted objects, deleted objects. It has the same purpose, but instead of going now to a relational database, let me just take one, for example, here, the insert, for example. What are we doing the insert? Well, we have this list, this map of entities, and when we want to give it into, or put it into the MongoDB data store, what we do is here we register it. It's actually going to happen in the insert at the end of the transaction. That's here. Don't worry about the code. The most important part is here, because you're talking about JSON documents, we're having to map our entities onto a JSON document. So that's what's happening here. So we're looping through this map, and for each of the entities, we're actually mapping it into a document, a JSON document. Now this is not really something fancy. Let me just show you. This is literally nothing more. So if I have, for example, the tasks, here we go. Nothing more than a bidirectional mapping from a document to a thing. There are frameworks that do this for us, but so far we really haven't found one that fits our needs or fits our use cases properly. And so at the moment we're just doing that. It's a lot of typing, but yeah. Philip, you might correct me later. I know what you're thinking, but it wasn't working.
Oh, it's not working with this.
Exactly.
Not yet.
Not yet. Not yet. Exactly. Exactly. But it would be cool though. Again, remember that query object that we had before. So if we now look at the, oops, sorry. If we now look at the query one, what is it? Find query. Here we go. You see that we actually create this filter. Remember that big XML that we were having, like all these lines? Well, this is now mimicking exactly the same in JSON. We're building up this kind of a list of what they call, or what MongoDB calls a BSON filter. It's a binary JSON structure, and we're just building up that whole thing. The point is that all of this is very familiar to what we were having. It turned out that replacing that, we were having a concept of a session already. We were having a concept of flushing at the end, and it all matches very nicely with MongoDB. Although I think I mentioned everything I wanted to mention. Yep, exactly. All right, let's continue. Right, so the implementation, I think I mentioned now a couple of times, is really about replacing these data managers with our MongoDB counterpart. Right? There's just a lot of work, a lot of testing. We're going to turn out alpha releases with that, and hopefully gather some people that want to try it out, work with it. There's a few people already on the forum that have tried it, which is great, but the more the merrier, of course. We're using the existing test suites to validate the implementation. So we have a big test suite in the relational counterpart. So we're using that test suite to run against the MongoDB counterpart. Once that is running, we're quite sure that everything is covered, and then we can call it like beta stable release. That's not yet there. At the moment, we're really doing a one-on-one translation, right? So we're really taking what we have in the relational model and just doing a one-on-one translation to the MongoDB model, and doing some small optimizations along the way. But the idea is that we first want to get to that test suite running, and then we can think about really, is there a way that we can better, probably there is, for sure there is, a way of storing this better in MongoDB, giving the JSON model and not the relational model. But that's secondary to getting the test suite running first. Now, I didn't put emphasis on it when I was going through the code, but actually all of the codes, and let me, while I'm talking, actually show it to you, all of the codes that was calling out to MongoDB itself, so for example, here in the MongoDB session, here we go. So all of the code, Mongo works with collections. Collections are like a name for JSON documents that belong together. For example, tasks is a MongoDB collection. Remember that I mentioned that there is this client session that you need to pass. Right? This client session, every call that you do, if you scroll to this class, you will see that the client session, that's the little thing that we have to keep during the transaction and have to use wherever we actually call out the MongoDB. Now, this exception here that I put on this one of the challenges while implementing it is that I think Taz and me, we spent half a day, if not more, on this particular one. It says write conflict, right? Write conflict. And now when I'm explaining it, it's going to sound really easy. But basically, we forgot at one point to add the client session, right? And I mentioned that they added this to the driver in a backwards compatible way, which means that they have function methods that work with a client session and without a client session, because for backwards compatible reasons, of course, nobody's using transactions in the past. So we were using, like, let's say, X number of client session enabled methods and one method that wasn't, right? And that seemed to work for most of the cases except for one, because they were doing like X number of operations in the database, but one was not part of this client session. But we were writing to an entity that was part of that client session, but this one wasn't. So normally you were saying, I'll write this because I got a conflict. Now it sounds easy when I explain it to that, right? When I explain, say just add a client session everywhere, but that's the hard work that we've done for you to make sure that that's all working. But let me tell you, this little exception, yeah, I still get shivers when I see it, because you're always staring at the screen and I'm just like, okay, maybe transactions don't work. At some point I called that and I said,
Doesn't work.
It doesn't work. I think they made a mistake or something. So anyway, it turns out we made a mistake, of course, like usual. It's not the thing you're using, it's your own fault. But anyway, it's just something I want to share. The other thing, one of the other challenges is that when you're writing lots of relational database stuff, is you're taking joins for granted, right? Even for simple things, you say, oh yeah, that data is that table, just join it and do like a big select and everybody is happy. You can't do that in MongoDB because you don't have joins. You don't have foreign keys. Everything's a JSON document and there's no relation to that whatsoever. That's why the one's called relation database and this one isn't. So what you need to do is a lot of denormalization, meaning that you need to duplicate a lot of data. You need to take your data and actually copy it into different places because you might have some queries that need it. As a developer, we, in this case, this is a lot of more work to guarantee data consistency. Because of course, when you duplicating is easy, right? You write it here, write it there. But then if you update something later or you delete something, you got to take into account that, oh yeah, it's there, it's there, it's there. And it's a lot of more work to make sure that data is consistent, which is exactly what a relation database of course gives you. So that's a lot of work that we've been doing. A simple example of that, it's a really almost trivial example, which shows the problem quite easily. This is the Mongo Process Definition Data Manager. Right. So, here we go. So in the relational database side of things, the use case is we want to find the latest process definition by a given key, right? So in the relational model, it's quite easy. You just say, give me select star from that table where the version equals, and then you do a little subselect. You say where the version is max, the version there. Quite easy, right? Everybody's done that multiple times. But you can't do that in MongoDB because you can't do subselects. You don't have joins. That's simply not possible. You can do like aggregators or aggregations they call it, but that's not really performant. So that's what this denormalization when it kicks in. This is a simple example. The latest one. What we do here is we fetch the previous one. We have a little flag saying is the latest one, and the new one that comes in, we actually set the latest one gets in the old one, and the new one is true, the old one is true, and at the end is going to be saved in the database. And then later on, here, later on, when we're querying for this, what we do is give me the latest one in this collection, and the key is this one, and the latest is true. And due to the fact that we have transactions, we know that this will be atomically done, right? So the latest and the newest will always be. There can't be another transaction coming in that sets the same process definition to latest false, because then the transactions would fail. That's why the comment here is saying that we're relying on transactional behavior. But these are kind of small things that you take for granted in the relational model, but when you don't have it anymore, you need to take into account and write it explicitly. But, it turns out that while we're doing these things, we actually have found some parts of the engine that we thought, hey, maybe it makes sense to do this also for the relational counterpart. So this exercise of running it on Mongo actually is also helping us to see it could maybe denormalize it also to improve the speed here, because we already know where we need to clean it up later on, which is what this slide is actually saying. So, and furthermore, over the last couple of years, and I think Taz already hinted at that, we have done a lot of work to make performance faster. And when you make performance and scalability faster, one of the things you've got to take into account is that going to a network is extremely expensive. Now, you can do a lot of things, on that local server. Once you have to go to a network, then it's a wild west. It's you don't know when something will come back. A network call is always the slowest component in your system. So that's what we're trying to avoid. Many of the features over the last couple of years, and definitely the last year, has been around denormalization, prefetching stuff. Prefetching, for example, in CRM, when you fetch a certain state, you're actually fetching all the states that are very close to it, because the chance is really high that you will also touch, definitely in CRM, that you will touch these things. So we're prefetching stuff to avoid an extra network hop that we otherwise should do. Entity counts. Entity counts are kind of like we're keeping on every entity whether it has relationships. So instead of relying on foreign keys, as you normally do, we actually, simple example, on a process to keep a count whether it has variables or jobs. And if it doesn't, it turns out in our benchmarks, it turns out that deleting and cleaning up was actually taking a substantial amount of work. At the end, when you stop your process instance or you stop anything, checking your state was actually a lot of work. So by having this little counter on there, we actually could improve performance a lot, because we can skip simply that cleanup if it's 0. And if it's 1, we actually know we have to do it. So these things, they really helped with the Mongodb implementation, because that's exactly what we also needed to do for Mongodb, and it was already there. But of course, the question that everybody was already asking, or had in his mind by now, is that, does it perform? And that's also the question we were asking. So what we did is we created this benchmark. So we took a couple of machines on AWS, and just standard machines being 8 core, 32 gigabytes of RAM from a processor, and then we ran Postgres and MongoDB with the same kind of thing. Now, before you start shouting, right, MongoDB is known to take a lot of memory. It just takes as much as it can. Postgres doesn't. So what we did is for Postgres, and I don't know if you can read it, but the configuration we actually used was like a tweak configuration that ensured that we used all the memory. There is some tool that we use to basically generate this configuration so that it's an equal, between quotes of course, equal comparison that they use the same resources. So the difference would not be due to that. And this process service, what it did, it brings, the code for this, by the way, is on GitHub, so you can try this out yourself if you want to. The process service does nothing more than bring the process from one stable state to another. In this particular case, from the start to, it's going to start, it's going to run to this service task, it's going to go up here, it's going to go to this sub-process, it's going to split it to 3 parallel paths. This is an automatic task, it's going to go into the join, it's going to do 2 automatic tasks into the join here, one, and here is going to stop. Right? There's also a timer here, which is going to register itself and do something. So, if you look at the relational model, what this means that every entry here is a separate database table. Every number here is the amount of rows in that table. So we're talking about 6 executions, 2 user tasks. You can read it yourself. So quite a bit of data. And we actually optimize this, of course, over the years. We kind of learn how to do tricks. For example, we're not inserting these things one by one. We're actually both inserting these things and stuff like that. So it's quite performant. But still, it's quite a bit of data. Just to get in your heads, there's quite a bit of amount of data that we're doing. And there's just 8 threads that are continuously pumping this, into Postgres in one the benchmark and the other benchmark into MongoDB. And just we wanted to see what's the difference. And the difference was actually the reverse of what we expected, which is always fun to see, of course. We expected, before we did the benchmark, that the queries would be faster in MongoDB because, of course, MongoDB is known to take lots of memory, so that means that you can query all this stuff in memory, so that should have been the fastest, right? And
so yes? Just a quick question, which version of Postgres did you use?
The 10, I think. Yeah, I think. I can look it up. I have it in my notes here. I'll look it up afterwards for you. A good question indeed. So we're saying that the querying, we expected that to be the fastest, and the inserts to be slower on MongoDB. Now, because we assume that transactions have been added recently, so we all know if you add a new feature, it's typically not the most performant feature from the first version, right? So we assume that if you insert with transactions, well, MongoDB is going to do a lot of work because it's V1 of their transactions, right? Well, it turns out it was the opposite. Turns out that if we do 1 million of these processes, and this is about, I think, 30 minutes or whatever, that Postgres was a bit slower than MongoDB, but the query, so we did like 5 million queries on that data. Queries like give me all the variables, give me all the tasks, give me like standard queries you often do in your own project. And it turned out that MongoDB was faster, the Postgres was faster in doing those 5 million queries. Now, before you go shouting and start throwing stuff at the podium here, although these graphs seem to indicate a relatively large difference, right? You got to take into account that when you divide by 1 million or 5 million there, when you divide the final number by that number, the difference for one process instance is actually less between MongoDB process and relational database is actually less than 1 millisecond. So even though it looks relatively big, if you look at it from one execution, it's less than 1 millisecond in difference. And of course, over 1 million of these, less than 1 millisecond, that adds up. Point is that that's actually pretty good, right, for MongoDB. But also, it also means that we have been squeezing out, as Baz has been saying, we're squeezing out really as much as we could, or at least as much as we currently have been able to think about, but of course, who knows what tomorrow brings. We have squeezed out a lot of the things about the relational databases. Relational databases have not been sitting idle. They also have been improving a lot of things. That's probably why the question about which version of Postgres you're using came from. So the conclusion is not, is this faster or this is faster. It's actually that two things. The transactional support in MongoDB is quite impressive because we didn't lose any data, which is very good. It's kind of what you expected when you use transactions in a data store. But the performance was also actually very comparable to the one we're getting on Postgres. And even, we have this kind of charts that there are sub-millisecond differences, which is, if you ask me, very impressive. When you take into account this is V1 of their transactions that they added onto a system that's out there for years already, having no transactions. To me, that's really an impressive technical feat, so to say. But it's a V1, right? So there are currently some limitations that you need to take into account. The most important one and the most hindering one, I would say, is the read and writes go to a primary node. So it doesn't matter how many nodes you have, you need to go to a primary node. That's not something really useful at the moment, and of course they're going to work on that. Second point is that in our benchmarks, adding more replica nodes, or nodes that would replicate the data from the master node, seem to have, in some cases, a negative effect, which didn't make sense because we also configured our drivers to go query against those replicas. So we expected actually that would have a better effect. So whether it be a wrong setup, it could very well be, or something else that we didn't properly set up, or just this is a way that it's currently implemented, that's unknown. We still have to figure that one out. And lastly is that transactions, if you look at the link here that for the MongoDB world of this year, transactions and new features of transactions, this is the blue line here which they're presenting, hasn't been, there's still a lot of things that need to be done. So this is like V1, but they're adding way more stuff to it. But there's lots of cool stuff that you can do with it, because MongoDB is designed for horizontal scale. Literally, you boot up two servers, you make them find each other, and they start, sharing data, in an automatic way. Of course, as a developer, it's not magic. You still need to think about your design of your data, of course. And yes, for example, Postgres has some really nice features around data partitioning, but that's bit more tricky to set up. I've done that, and it's a bit more complex to set up compared to just booting up a MongoDB and run with it. Another really interesting use case is sharded clusters. So two simple examples is that sharded clusters means that MongoDB actually on the lowest level, you can say this is the key, this is a property in JSON that I want to base myself on to either go to this server, to this server, to this node, or this node can even run in a separate data center. Doesn't matter, right? That's built into MongoDB. So the easy one that by default everybody thinks about is, of course, you have a tenancy, multi-tenancy. So this tenant goes to that server, nodes, these one go to that data center and stuff like that. Another one could be like sharding based on a process definition. Well, this is a more important process, more priority. You put it into that service, they have more resources. Or jobs, you have these asynchronous jobs, they're a high-paying customer, so they need to have better resources, stuff like that. And of course, the last topic of this slides, of this presentation, is the big data use cases like machine learning. And machine learning, as a process and case engine, we're actually in a prime position, so to say, when it comes to data, because a engine, process engine, case engine, is on top of user interaction with forms typically, maybe mobile apps, service calls, but there is a bird's eye view of the whole kind of infrastructure that you're calling out. So there's very little process or frameworks that actually have a good view on the data as the case in a process engine. So that makes it really easy or natural to go into the machine learning. So MongoDB, being big data, whatever that means, that's what we're talking about this presentation, has by default some nice stuff for that. For example, reactive drivers. Of course, there is work going on right now for relational databases to do that, but still, MongoDB has that for ages. Streaming, so they have by default streaming APIs, which is really useful for machine learning, as you'll see later in the demo. Basically, this big data concepts, that's what they started from, and that's why the machine learning basically works naturally on these things. So what we're going to do is, we're going to start in the demo, we're going to run a lot of processes from the start to an end. We're going to feed this data. So what we're going to do is we're going to run these processes. So don't worry about what it actually is. It's like a very simple load review process. We're going to run this constantly, right? So this is going to generate lots and lots of data. Secondly, we're going to feed all this historical data into the machine learning algorithm. And I'll show you later how that actually looks like. Because it sounds a bit of magic, but it isn't. It's just code. Let me show you. And then I'm going to show you how we can use this data to see if there's something can be improved here. So what we're going to do is we're going to look in this process for human decision patterns. Now, human decision pattern in this case is, for example, this user task. It's a user having to do something. There is a form attached to it. You don't see it in this diagram, but there is a form to it, trust me. And you either go up, straight ahead, or down, based on something you fill into the form. Right? So a human decision pattern is really user task followed by exclusive gateway followed by something that references the form that was defined here. Once we have that pattern found in code, then we're going to trace back. We're going to trace back to the beginning of the process. Then we're going to see, we're touching this service, we're touching this user task, and we're touching the start of the process instance. And we're going to see in the model, we're going to see what kind of data that comes out of it. We're going to check this service is going to produce this data. This user task is going to have this form, which means that we're going to have this data. The process is started with this form, which means we're going to have this data. So we're going to have a big list of data. And once we have that big list of data, what we're going to do in the demo is we're going to use this Spark decision tree algorithm to basically see if there are patterns in the data. So the idea is that, when we look at this process, the idea is that we want to see if, when we're here, if there's a pattern here. So we're going to check if there's data at the start of your process instance that can influence going up straight ahead or going down. And even, can go away with this. This means that this probably is like menial work that doesn't really need to be done by somebody because it's always the same. And we're going to try to see if that, within a certain percentage of confidence, of course, can be automated, can basically be replaced by a service task. A service task saying, like this, right? So the architecture that we're using is quite simple. So we have this process service that just is going to, execute these processes. We're going to save those into MongoDB, of course, with the stuff that we've been showing. And then we've got something called the decision analysis service. And basically what this one does, it is going to use MongoDB to fetch the data, execute that decision tree algorithm, and produce patterns, right? Very important here is this line here, is stream as a resilient distributed data set. It's something from Spark, from Apache Spark. And basically, what this means is that you have a cluster of Spark nodes, is this will make sure that every node fetches as much data as it needs. So no node is going to fetch all the data, because typically you can't fit it into memory. So the algorithm of Spark and this RDB concept, and this is why I was saying that MongoDB having the streaming API is really important, streams that into whatever number of nodes you have in your cluster. Now people that have seen this presentation, maybe we did something last year, if you look at that, what we did there is there we used asynchronous history with Elasticsearch. This is not necessarily a bad architecture, or the other one is not better. The point is that by using MongoDB, we could get away with this message queue we were having here, a listener service, and Elasticsearch that was actually doing the same thing, because Elasticsearch also has the RDB concept. Just as a side note, as people that have seen the presentation of us last year, again, this is an alternative if you're using relational databases. If you're using MongoDB, you have less moving parts for this particular use case, of course. Anyway, let me just show you how that looks like. Here we go. Swap to that one. So what we have here is a very simple, I already showed it to you in the beginning, a very simple configuration, and what is hooked into it is a very simple quick and dirty REST controller, as the name implies. A quick and dirty REST controller that's not going to do nothing more than, as I said, starting these process instances as we speak. So what I'm going to do is I'm going to start this while I'm speaking, and I'm just going to trigger that. This is going to basically add data into MongoDB, right? So here we go. I'm just going to call localhost start with 1,000 process instances. Here we go. It says I trigger the start. It's an asynchronous start, so it's just going to starting to do that. I don't know if you can see this, but this is basically Mongodb Hub. There's now a new kind of flowable data replica sets in MongoDB. And you see that there's all these are collections. And for example, the one with the historic process instances, you see there's now 372, and if I click and go back, there's now 442. So you see that this, while I'm talking, there's new data being fed into MongoDB, right? Now, the thing we're going to do is this decision analysis service. I'm not going to go into detail here, because what it does, and the code is all on GitHub, what it does, that pattern matching that I talked about, so basically trying to find these patterns of human decisions with a form, with an exclusive gateway, that's what's happening in this service, is going to basically calculate, or basically gather all the data, possible data that you can have, and it's going to give it into Spark. And that's the last kind of thing I want to show you before running it. This is the Spark stuff. So remember, this is quite heavy stuff. So it starts the journey as a MongoDB RDB resilient distributed data set. We're going to group the data. That's the first job we're going to do. We're going to group the data by process instance. And remember that if you execute this on a cluster of nodes, that this could be executed on X number of nodes. It's kind of like a divide and conquer kind of forgetting the name now. There's a famous kind of MapReduce algorithm. Right? So this is actually going to MapReduce this across a cluster. Then we're going to say, well, only the ones which already have a output variable for this particular step, that's the one we're interested in. And at the end, we're going to map it into mathematics, into numbers, basically. So we need to have a feature array, basically saying these are the variables, these are the potential steps going into this particular task. And then we need to have what they call a vector, the vector being the actual number for that feature set. Again, if you're interested in these things, have a look at it. It's not that hard, but it's kind of, they use this whole machine learning thing, they use their own kind of language, and that takes a bit of time to get into. And then what you're going to do at the end here, you're going to split up your data set into training set, into a test set, as you normally do, and you're going to generate basically a prediction model. And that's, at the end, you're going to see it being output. So that's what I'm going to do now. Again, it's a Spring Boot application. I have to, you can't see it probably, but I have to point it to my Spark installation on this machine. And it's going to basically, what it's going to do now is going to stream stuff from MongoDB. It's going to do all of these, chained lambdas, and they need to be lambdas because they need to be immutable. So the stuff that you're distributing over your cluster, they need to be immutable because otherwise you can't really MapReduce. So that's what's going to happen now when I'm talking. And here we go. I don't know if you saw it already. It's very simple because I don't have that much data, of course. Come on. But here you see that basically we're outputting the potential values that we think we have. For example, in this particular process, we had a variable called nationality, and there were like these kind of potential values, but then the full name, well, it could be anything, right? The income could be anything, the age could be anything. Well, that's probably constrained, but it still could be anything. These are really, you can imagine that this is a drop down, like nationality is a drop down in the form, and this is like just a text field that you fill in. And every time that you execute this, it's always, you don't know what happened, but in this case, what it said at the end, it basically generated a very simple one. Now, I've got more complex one afterwards if you want to see them, where I've got more data and it's like 4 layers deep. But just for demo purposes, I made it quite simple right now. But basically, this is the decision tree representation. And it says here that basically we learned that if you're over 50, you're going to be rejected. If you're lower than 50, you're not. And which is a very, yeah, it's not a very nice kind of algorithm here. But the point is that now we could really go into this process. And I mean, we have a demo for this. My time is now up, but we have a demo where actually we're using this data. We're actually using this data to feed back into UI for a modeler, for an end user, basically suggesting, hey, look, our data indicates that whenever somebody fills in that I'm over 50, we always go into the rejection. So what's the point of actually still looking at this case if you're going to reject it anyway? Is this true? I mean, technically we can. Technically we could just swap it straight ahead, but nobody's going to really like that. So we could suggest that to the user, to the modeling people, the business owner, basically saying, hey, our data indicates that this is the data indicates this. Do you think this is valid, right? And that's really, where this is going. I got a demo about that. If you want to see that, just come and find me where we actually do this kind of thing. But I think Paul was waving his hands there, and it's now time to close off.
Well, yeah, the food and drinks.
Very important.
Exactly, yeah. So we've got half an hour break now, and of course there's plenty of time to ask more specific questions. But if there's anyone's got maybe one question before the break, that'd be great.
It's 2.
Or you can ask at the break time.
Are you going to foresee a migration between the SQL and the non-SQL database? Because if you want to test it, it would be good if you have something like...
That's a good point. No, there's really, at this point, not yet. I think that really will depend on if and how popular that will be. I mean, if we see that everybody starts doing MongoDB, of course, yes. If not, then... like I say, it's first of all, it's a good validation of our architecture. Secondly, we have found some really nice improvements during the MongoDB stuff that we can reuse for the relation counterpart. So it's not like this is just throw away. This actually helped evolving our engines. But it really will depend on people picking it up and the market just reacting and just doing it. So yeah. But of course, having written it, it would be really cool that people, of course, everybody use it.
So yeah, we've got a break now for half an hour. So there's a light selection of snacks at the back and coffee and water and things like that. So if you want to break out, and everyone is free to use, obviously the restrooms, things like that. But half an hour to start catching up and asking more of the questions. And next session at 11:30 is going to be with Grant from Dow Jones and telling us what they're doing. Thank you very much.